Welcome to part 4 of this series where we learn how to use LangChain library with the Node.js and TypeScript to build apps using the OpenAI API. If you're watching this for the first time and get confused, I strongly recommend that you go back and watch part 1, 2, and 3, and that will clarify a lot of things for you. And this time, we are going to train our language model with our own custom data fetching from a text file. For that, we need this text loader from the LangChain library. And once we load the data, we're going to split it into smaller chunks using this recursive splitter. And those little chunks we're going to use to create vector embeddings using the OpenAI embeddings from OpenAI via LangChain. And once those embeddings are created, we need to persist the data. So we're going to use this Faiss vector store, which we can query later on to create our custom chatbot by using these libraries: retrieval QA chain, load QA stuff chain from LangChains. And that being said, let's get started here. This is our usual constructor where we create our OpenAI model with GPT 3.5, temperature 5, and this time we're enabling streaming to true, and that streaming will give us answer in tokens on our standard out or command prompt. That's why we're not going to need any console logging. So with this model, now let's move to our actual method here, process text to vector store. So first off, let's load up the text data. Let's go see where it is. Source docs right here, and that would be OpenAI FAQ. So this is basically a Q&A type of text I got put together. This has the information on OpenAI as a company, but what I did, I just changed the name to CyberEdge Group. Instead of OpenAI, I just changed that. And these are like, if GPT-3, I just turned it into CPT-3. That's all I did, just to make sure that when it's answering, it is not going back in and answering from its own information. It will use just this data. So this text file we're going to be bringing in using the text loader. And this text loader, we're going to then, since this is an async function, we await it, text loader.load. And we load it up in this variable called docs, and then we call in the splitter, and this time we're using the recursive character text splitter class. And basically we're creating the object by telling it the chunk size. Basically it's going to be breaking that text down into 200 character chunks, and chunk overlap is basically what is common between two different chunks. Up to 50 characters will be common, right? Just so that we make sure the data is accurate. So once this splitter is created, then we create our new document, putting it through the splitter. Take this document, putting it through the splitter, and we get our document into the right format. And here it is ready for the embedding. And right here, we're going to go ahead and create our embedding object using the OpenAI embeddings. And this is basically this guy. OpenAI embeddings is coming from LangChain embeddings OpenAI. So this is where we're using the OpenAI API. So once the embeddings got created, then we are creating our vector store. And this time we're bringing in the Faiss store, which is a vector store created by Facebook. Very reliable, very fast, but this does not need any separate type of installation like a database. This is a file-based one, fast and simple and scalable. But if you're doing something really professional, I recommend using something like Chroma DB or Pinecone or Redis, etc. They're in the cloud, they are scalable and good for professional stuff. But for learning, this is more than enough. So here we pass now our documents and embeddings to create the actual vector store. And once the object is created, then we await it, because this is also another async function, vector store.save, and then we give it a folder name, vector store. So where that is right here, vector store txt. Actually, let's fix that. Okay. So now it knows where to store it, and what is that? There's nothing, empty right now, right? So once this file is saved, then our vector store will be created, and next thing we'll be doing is go and query that database. But for now, we're going to stick to this. So now let's go to our index file, and this is from the last lesson. So let's remove that and create const LangChain txt and new LangChain. And this is the class we're going to be bringing in, because this is our class or module, and we import it right here and save. So once that is done, let's call the method. Now we know where the text file located. We know where our destination is, this one, and then our method name is process text to vector store, right? So dot process text to vector store. So now that we have our function ready, let's save that and go here, and let's run npm run dev. Actually, let's give it a message so we know that it actually finished it properly. So let's go put it a console.log Faiss vector store created successfully, right? So once this is done, it's going to give us this result. So now we are ready to go, and hit enter here, taking its time. Oh, there you go. Faiss vector store created successfully. And to verify it, we're going to go look under the vector store txt. We already see the index and the vector store got created. And this vector store has the data from our source file, which is OpenAI FAQ. Only the names and stuff got changed just so that we can verify properly. So now that we have our vector store done, the next will be asking it questions. Let's do that. All right, so now that we have our vector store ready using this, now let's go to the next method where we are going to use the Faiss vector store. That's why I named it use Faiss vector store. In this function, we're going to be bringing in a string, a question. Let's say here, when the Cybereyes company was started. So this is the string coming in, and we are creating our embeddings object. Before you saw, we created this embeddings object just to store it, and this time we need this to put it back, right? Put it back out of the store. So we're passing this object here and giving it the location of our vector store, which is right here. So now the vector store is restored, and now we're going to use this vector store to ask a question. And for that, we use retrieval QA chain, and which takes attributes like combined document chain, and here we also use that other function load QA stuff chain, this model, and then we create a retriever using vector store dot as retriever, and then return source document to true. At this point, we're not going to see the effect, but that means basically it's going to give you the reference where it's actually collecting the information from. But I will show you that. But when I turn this verbose to true, when you're going to get all the details, and that's when you're going to see the source one. But other than that, any one of them, if you have more questions about, all you have to do is that just copy that and then go here. Go to the chat our docs and say, what does this mean? Paste it here, and this guy will very promptly show you what the answer is. And even if you want to be asked the details like a code example, etc., it's going to do the same. So go do your research and ask it whatever you need to know. But right now, we just have our chain created. And simply, we're going to await the chain to get a response because this is an async function, chain.call, and it takes an object with a query parameter. And here, I'm passing the question that I collected from my function or the user, and this is where the chatbot will come through. You can have any source, like a GUI chatbot, whatever you build. Right there, when the user hits enter after sending the text, that's what this string is. I'm sorry, this question is, and we're going to use it here. And let's go ask it the question: when was Cyber's company started? So let's go see the output, npm run dev, and let's see what it says. Boom, there you go. Cyber's group was established in December 2015, which is basically the time for OpenAI company's establishment. I just changed the name. So now I know it is actually telling me from the document. To verify, we can always go to source doc, and right there, Cyber's group established in December 2015. So now let's ask it another question. What is call E? Basically, I'm asking is, what is DAL-E? The OpenAI image model. So let's save that and see what it says. There you go. Image from textual description, showcasing AI's understanding of creating complex visual content. That's basically DAL-E it's telling me about, right? All right, so this time let's test it a little bit further by turning this verbose to true. And I also added the console.log the answer response.txt, so that we can actually get the answer on screen this way, because you'll notice once verbose is turned on, it goes completely crazy. But you need to know this, because this will be very handy in troubleshooting purposes. And also we get to see what return source document means, right? So now that it is set, let's go back, and okay, we already enabled it. Now let's go to an npm run dev, asking the question, and boom, look at that. So our final answer is some of the well-known products developed by Cyber's group are GPT-3 and Codex. Basically, it's trying to tell us the GPT-3 and Codex by OpenAI, since I changed the name. But this way we know that it's coming from the document. But this is how it's getting to where it's getting to. Every step of the way, it's asking a question, it's going back to the source, and including the line numbers, from 36 to 36, from this to that. And this is what we mean by including the source document. And this will definitely help when something does go wrong to troubleshoot. And that being said, let's move to the next module. All right, so last time we processed our text, created a vector store using this function, and then you utilize the Faiss vector store to test out the chatbot question answering session. And this was our location for the vector store text, and this was our Faiss index and data store. And this was our target file, the text file that we actually fed it to the database. So this time we are going to use a vector database, a remotely installed vector database, kind of like Pinecone. Only difference is Chroma DB or Chroma is free. Pinecone at one point you have to pay, but here you can actually self-host it and use it at your will to test it out, especially for learning. This is also scalable, so you can actually build out a production application using it. But before I get into it, let me first check out what's the status. I have another class here just to test out my Chroma DB installation. And here I have like a get Chroma collections, and to check, to list out all the other databases that are currently hosted. Create Chroma DB, delete. We're not going to need all these for this. We're only going to use this get Chroma collections method here. So we just instantiated the Chroma test object using this class, and now we're going to enable this just to see what database are already hosted in there, right? So let's go check it out. And before we run it, let me just show you, this is where digital ocean droplet here. And if I just make it larger and say Docker PS, and this is where I see my Chroma server 1 hosted in port 8000. And if you want to know any detail about this installation process, you just come to my channel and look into this video called hosting Chroma DB. This has every step you need to know how to install and host a vector Chroma database in a DigitalOcean droplet. That being said, now let's test it out. Okay, boom, there you go. So currently we're making a query to our database, and we're finding that there are 2 collections there. Collections means basically tables. And we can do our query and everything based on this table. So now we have most text call 1, and then Chroma most call 1 underscore 1. So these are the 2 collections there. So let's for now, let's disable that, and let's go back to our LangChain class and see what we are doing here. So basically we're calling it process text to Chroma DB, right? Only thing from the LangChain we need is all the way up is Chroma. This Chroma object from LangChain vector store Chroma. So now here we just use the same text loader to load up the FAQ text from this source right here, and then loader.load to the document, and then same splitter we use to chunk size 200 and chunk overlap 50, exactly the same way we did before. And then we store our split up document under the documents variable. Only thing now different would be this vector store, because this time we are calling the Chroma class awaiting, because it's a async function. So Chroma dot form document, and this time we're going to pass it our document and the OpenAI embeddings. We're just instantiating it right inside it, and here we are giving it a collection name. The collection name, though, we are bringing in as an argument, string argument, when we call this function. So we can actually change the name as we go. So, and once that collection name is received, and this is the URL where our database is actually up and running, port 8000, as you saw in our Docker setup. And then this is the collection metadata. This is something extra. You can look it up in the docs. Basically, this cosine is the best way to store the data so that the queries are much more friendlier, right? That being said, after this is done, I am actually console logging it, giving it the vector store name, whatever it just created, and it's going to tell us vector store got created and with this variable, right? So first thing we do, we create the database. So let's go here. We already instantiated LangChain text, and this function or this method would be process text to Chroma DB, as you see right here, and we're calling it moose text YouTube, right? So let's save that. Come here and see what happens. Oh, there you go. It actually successfully created moose text YouTube. But just to further verify it, let's disable this and make another clear query to the Chroma DB as we did before, to see, because last time we saw 2, right? And now we're seeing the previous 2 and the new one. So now we know we have our collection created, and which is healthy. Now let's go to the next method. This is going to be very similar to the one we had before, only this time we are creating this embed using the OpenAI embeddings. That's fine, but instead of the Faiss store, we are using the Chroma, and the function is from existing collection embeddings. And in collection name, we should probably give it moose text YouTube, right? That's what the name is. Yes, let's copy it from here and replace it, because this is the one we just created with our document. And we're giving the URL location where the database is. Once that is done, our vector store is created, and now we just use retrieve QA chain, and we pass along the vector store, and everything else is the same as before. And the prompt would be our question, and we are getting it through the question. We're getting it as a string argument to this function. So now let's save that and go back here and ask our question. And I've already updated our object-based method, which is this: use Chroma vector store, this guy, and we're going to pass it our question string just like before. When was Cyberize company started? And let's see where we are here. We are ready to go and save. Let's see what happens. Oh, there you go. Cyberize Group was established in December 2015, just like before, but this time we are getting it right from here. Very professional remote database setup, just like Pinecone, only free. So let's ask it the other question, this cal E. Let's go and see. Boom, and this time it gave us a little bit more descriptive answer, which is great. And last but not least, we're gonna go ahead and ask our third question. What are the products of Cyberize? Save, and let's see what it does. Oh, same result, GPT-3 and Codex. And with that, we conclude the part 4 of the series.